Okay, here it is, last issue. So click and close, put phones away, let's have a little look here. So this is kind of just one little artifact from yesterday that I just wanted to touch base on. There's one like this on the final, so I wanted to hit it. This is the question from the final, in fact. Simplify the expression and write your answer with a rational exponent. So what's the difference? No difference from what we did yesterday, only instead of writing it with a radical, we're just going to write it with a fractional exponent. Okay? So this is actually easier than the ones we did yesterday because it already starts off written with exponents, so we can use our properties of exponents. When we divide like bases like this, what do we do with the exponents? What do we do if we divide like bases? We subtract, yeah. So this is just equal to w to the 3/5 minus 1/4. And the part that we really need to focus on then is just, that's subtraction problem. That's no big deal. How do we subtract fractions?
Make the bottoms like numbers.
Yeah, make the common denominators. So what's my common denominator going to be? 20, yeah. So I'm going to multiply the first one by what divided by what? And the second one by? Good. So then we're going to end up with
12/20 and 5/20.
yeah, good. W to the 12/20 minus 5/20 is W to the what?
7/20.
7/20.
That's it.
That's it.
And that could be reduced, we have to.
Yeah, you would reduce it if you could, right, but you can't, so it's just W to the 7/20, right? Okay? Okay. Good, good. Okay, so there's that one. Now the last issue we got to talk about, and we've already reviewed this a little bit, but the last one we want to do is solve some equations, radical equations. Okay, so find the solutions to the equation, right? You didn't even notice my little heading there? Okay, all right. I thought I'd get a little better response. All right. Okay, so what do we do here? Some radical equations, Rob. Come on. So what do we do if we're solving a radical equation?
Can you isolate x by square rooting the?
By squaring it, right? So the steps are, remember we talked about this reviewing for SBAC. So this is really old hat stuff. We isolate the radical, and then we take both sides to whatever power we need to get rid of the radical, right? So phones away, please. So with this guy here, we've already got step one, isolate radical. Step one done, right? We've already got the square root of x minus 10 equal to 11. So step two would then just be square both sides, right? Yes. So that leaves us with x minus 10 equals what? 11 squared, because we're squaring both sides, right? I want to do that. So we get
121.
Okay, 121. So then we end up with the solution x minus 10 equals 121. So what's x equal? 131. Good. Okay, but step three, what's step three? Yeah, we got to check all solutions, right? Because when we take both sides to a power, we can introduce those extraneous solutions. So we always must check all solutions, okay? So if we plug that back into our original equation, we end up getting the square root of 131 minus 10 equals 11. Well, that's true, isn't it?
Yeah.
Right? So that's true. It works. So our solution is 131. Okay? Right? Let's try another one. Okay, so this time we've got radicals on both sides, but they're both isolated, right? So what am I going to do here? Square both sides. Right, so I'm just going to square both sides. So we're starting off with step 1. That's what we start with. 4x plus 7, square root of 4x plus 7 equals the square root of 3x plus 6. Good. Okay, and so let me just cheat a little bit here. Get kind of lazy sometimes. So all we're going to do here for step 2
Bless you.
is square both sides, so we get the solution, or we get the equation 4x plus 7 equals 3x plus 6. If I solve that, what do I get? Subtract the 3x, subtract the 7. What do I get?
X equals
-1. Okay? Got to check it. So we'll plug that back in. Whoops. So step 3, we'll plug in to our original equation. So we end up with the square root of 4 times -1 plus 7 equals the square root of 3 times -1 plus 6. What's that give us? Square root of 3 equals square root of 3.
Whoa.
Right? So,
That is pretty radical.
That is radical.
all right. Okay, good. Next one. Step 1. Square both sides. Yeah, it's already isolated, isn't it? So we can just square both sides. All right, so let me write this down. Here's our original. Okay, so step 2 then. Now we got to be just a little bit careful with it. Step 2. We're going to square both sides, which means I got to put that in parentheses, right? Okay, so on the left side, that's just going to undo the radical, right? So I'm going to get -5x minus 24. On the right side, I've got to square out x plus 6. So we can either just multiply it out by distributing, which is you can always do. What is it not equal to, though? What's the most common wrong answer here? X squared plus 36, right? It's not that. It's not x squared plus 6 squared. Everybody agree? It's x plus 6 times x plus 6. It's more complicated. So like I say, you could either just multiply that out, or hopefully you remember the pattern. What's the pattern for
A squared, right,
yeah, a squared
plus 2ab
plus 2ab plus
b squared.
b squared? So hopefully you remember the pattern. If not, just multiply it out. It's fine. Either way, what am I going to get? So I'm going to get a is x, b is 6. So I'm going to get a squared, what's 2 times x times 6? 12x plus 36. Okay. So then I get this equation. Well, that's no big deal. That just, what do I do when I get a quadratic equation like that?
Quadratic form.
What do I do? Okay, but it's not in the right form. What do I always have to do first?
Get everything on one side.
Get everything on one side. So we're going to push everything to the right this time, aren't we?
Because there's less stuff on the other.
Well, because we want a positive number of x squareds,
Oh.
right? So we're going to add 5x. Okay, so all that stuff cancels. So I get 0 equals x squared plus
I can cancel
17.
-24 with 5x.
Oh, you're right. I didn't need to cancel it with 5x, did I?
No, yeah.
I got going so fast there. I just get so excited about math sometimes that I just can't contain myself.
I have the same thing. Excited about math.
Oh, you know what? It's easy. Trent gets the same way.
Yeah.
Gets
Not
pretty
about math,
excited.
though.
He gets pretty, oh, come on, Trent gets pretty excited about math.
Trent, do you get excited about what's in the book?
Oh God, he's the only one who does that.
So if I add all this stuff up then, what's that gonna be, 60? Okay, so we got the 0 on the left side. Let's just flip it. It's always nicer to have that 0 on the right side. Now we got a quadratic equation in standard form. What are my options? Magic numbers, hopefully, or if not, quadratic formula. So do we have magic numbers that multiply to 60 and add to 17?
We must.
Yeah, we do.
9 and
Must.
8.
Let's think about the different ways we could get that. We could get 60 times 1 is not going to work. 30 times 2 is not going to work. Those don't add up.
15 and 4.
Oh, 20
15.
and 3.
No. 15 and 4. Oh, I guess we missed 20 and 3, didn't we? I'll go back. That's not going to work either. 20 and 3 add up to 23, right? 15 and 4, what's next?
14.
No, 14 doesn't.
23, you can subtract 13 from 20 and get
10 and 6.
No, but they have to add to 17.
20 and 3.
Well, no,
20
because
minus
it's,
3.
because they have to both be positive, so those would add to
Oh.
23, right? So if we make another column, oh, that's not right. For the sum, we'd end up with 32, 23, 19, oh, there's 17. Right?
Oh.
So there's my numbers, right?
I think he was trying to figure out the
Okay, but you could use the quadratic formula. This is way easier if you can get it to work. So what are my solutions then?
Negative 12. And
Okay, so what's the next step?
Check.
I gotta check them, yeah, I gotta plug them in and check them, right? So next step, let's plug those into, oh, come on, let's just do it here. So plug those into this guy. Okay, what's that gonna give us? If I plug in negative 12, let's try negative 12. So if we use negative 12, I get the square root of negative 5 times negative 12 minus 24 equals negative 12 plus 6. So that's going to give me 60 minus 24 is 36. Square root of 36 equals negative 6. Is that true?
Yes.
What's the square root of 36? 6. So that is not true. So x equals negative 12. We have to eliminate, right? How about the other one? If we try x equals negative 5, that's going to give us the square root of negative 5 times negative 5, right? Minus 24 equals negative 5 plus 6. So that's the square root of positive 25 minus 24 is 1. Is the square root of 1 equal to 1? It is. Check. So x equals 5 works. That's our one solution. We didn't get both though, right? One of them failed and one of them succeeded. Okay? All right, last example. So that's a little bit harder, right? Not a big deal. Remember, when we squared both sides, it just gave us, we had to be a little bit careful with that, but we got a quadratic formula we could solve, right? Okay, last one is a little bit challenging. This is actually from the final, but this is the hardest question on the final by far. But you'll get it. We're going to go through one like this now. So, so step one, we've got our original problem, right? Now, what's the issue that you see with this one right now, do you think?
There's something outside of the square root thing.
Yeah, I can't isolate both at the same time, so all I can do is isolate one at a time. I've got one of them isolated, right? So when I square both sides, this is gonna look a little weird, but we know how to deal with this stuff now. Okay, so we end up with step 2. There it is. Okay, we're just gonna square both sides, but notice when I square both sides, on the left side, there's 2 parts, right? So I'm gonna have to put this whole side in parentheses and square it. So what's that gonna give us? Well, the right side's easy. On the right side, I'm just gonna get x plus 19, right?
Plus.
But on the left side, I'm gonna get square root of x plus 7 plus 2 squared. So once again, I can just multiply that out, and let's look at that. There's 2 ways I can do that.
Oh, x squared plus 49 plus 4.
No, it's not that simple. But let's look at how, let's go to the next page and let's just focus on this one issue for a second. How do we do this? So we don't have to use the pattern. We could just do this, right? We could just say square root of x plus 7 times 2 times itself and distribute. We can do that, right? So what's that give us? If we distribute the x plus 7, I'm going to get square root of x plus 7 times itself is x plus 7 plus square root of x plus 7 times 2, 2 square roots of x plus 7, right? I get 2 of those radicals. So I get plus 2 times the square root of x plus 7. If I distribute the 2, I get 2 more of them, right? And then finally 2 plus 2 is 4. And so if I add up my like terms here, would you agree that those are kind of weird looking like terms, but they are like terms? I get 2 of those square roots plus 2 more of those same square roots is how many? 4. Okay, so I get x plus 7 plus 4 times the square root of x plus 7 plus 4, and I can even add up the 7 and the 4, right? Those are just numbers. So I end up with x plus 4 times the square root of x plus 7 plus 11, right? Now I could, though, we could use our pattern, right? We know that a plus b squared, Aspen told us, is just a squared plus 2ab plus b squared. So then this must just be equal to a squared, the square root of x plus 7 squared, you already told me, is just x plus 7, right? Plus 2ab, 2 times the square root of x plus 7 times 2 is just 4 times the square root of x plus 7, right? Plus 2 squared is 4, right? And so if I just add like terms, doesn't that get me right down to there? Okay, so the pattern still is easier. Okay? Either way, though, we're just going to get this. So you can go back to the last page and just put that down here on the left side, right? That's what we got. And we squared all that out. And on the other side, we already said this is easy, right? Over here, we just get x plus 19. Okay, so we get an equation. Notice that in our equation now we still have a radical. So what do we have to probably do? We still have a radical equation. What do we have to do here? Well, we got to isolate that radical, don't we? Right? So what's that mean? We could subtract away x from both sides. Well, that's convenient. Look, the x's cancel. And then we're gonna subtract 11 from both sides. And we end up with 4 times the square root of x plus 7 equals 8. Next step, divide by 4. And so we end up with the new equation. Square root of x plus 7 equals 2. Now what do? Square both sides. Good. So if we square both sides, we get x plus 7 equals 4. And so what's my final answer?
X is -3.
Okay, but what must I do, of course?
Check it.
Gotta go back and check it. So we'll go back to the original equation, which is right here. Oops. And we'll check that. Okay, so if we plug in -3 for our x's, we get square root of -3 plus 7 plus 2 equals square root of -3 plus 19. So that gives us square root of 4 plus 2 equals square root of 16. Is that true? Square root of 4 is 2 plus 2 is 4. Square root of 16 is? Yeah, it works, doesn't it? Right? It checks. So -3 is our one solution. Okay, make sense?
Mhm.
That's it. That's it. You may get a Chromebook and get to work.